11 3 11 11 I'm sorry 11 let me see, this is section 1110 number 6, 1110 number 6. This is called, the way it is, this is a logarithmic integral, and you want to express this, let me see, is it the same? Yeah, as exponential in the exponential integral. Yeah, so you have to use whatever is needed to manipulate the integral so that this turns from a logarithmic form into exponential form. You know, the first thing that comes to mind, substitution. What would you substitute to put that into exponential integral? The first thing that comes to mind, substitution. That's the hint. I mean,
how would I end up substituting?
I would try to call u to be ln 1 over t. So I would make this substitution and then make the necessary adjustments into the integral to see if this substitution turns my integral into an exponential integral. So when you call u equals ln 1 over t, I would still need to find dt, so I would have to differentiate this.
Right. And differentiating ln, how would you do that?
Gu, the derivative of ln is 1 over the argument, 1 over t, times the chain rule, the derivative of 1 over t, which is minus 1 over t squared.
Right.
So this becomes, just simplify here, you get minus 1t cancels 1t, and you get minus 1 over t. I forgot the dt here, so this would have to be dt. So then that means du is equal to minus 1 over t dt.
Okay.
You also have to change the bounds. Okay, so from this I conclude that du dt, so that means dt is equal to minus t du. That enough hint? Now from here you still have to figure out what t is, and then change the bounds of the integral. So yeah, now we would have to change the bounds. So let's see, and furthermore I also have to get rid of this t here because I'm doing substitution. Yeah, so from this I can say e to the u equals 1 over t, which means t equal e to the minus u. And then I could replace this t by e to the minus u here. So this becomes minus e to the minus u du, and that enables me to replace dt with minus e to the u du. Okay, let me go see the bounds now, what they are. You got the bounds? Let me see if my bounds match your bounds. Yeah, so for t equals 0, so let's do the bounds here. For t equals 0, right, plug it in the u, so we get u equals ln 1 over 0. Well, 1 over 0 is infinity, and ln infinity is infinity. So yes, at t equals 0, u equal infinity. That's what you got? 1, oh yeah, sorry, minus infinity, because the ln approaches minus infinity at 0 plus. No, it's plus infinity. It's 1 over 0, you get ln infinity, which is infinity. As x goes to infinity, ln x goes to infinity. So the answer is infinity. And at t equal x, u goes to ln 1 over x. And so plugging this back into the integral, then 0 to x dt over ln 1 over t. Okay, let's do the substitution now. So this is minus e to the minus u du over, we called ln 1 over t u, so this would be u. Okay, du, wait, so yeah, mine over u, and then the bounds are 0. At 0 it's infinity, and at x it's ln 1 over x. Now I could reverse these bounds at the cost of this minus sign here, because if I just make that a plus, I would get ln 1 over x to infinity, and I would multiply that by a minus, so we would get e to the minus u